Math 3, Unit 2, Section 6. Today we're going to be talking about factoring sum and differences of cubes. Earlier this week we talked about factoring perfect squares. You'll notice the difference. Cubes have a cube. They're cubic. And then also we could only do differences of squares, and with cubes we can actually do sum and difference of cubes. There is an acronym that you will find used a lot when you are factoring sum and differences of cubes, and you will hear people say SOAP. And so SOAP represents how you know which sign to put in here. So we're going to talk about that first and kind of put everything together. This S right here stands for the same. Okay, and what I mean by same is if you notice in this original problem here, there is a plus sign, and in this parenthesis, it is the same sign as it was in the original problem. Next, we have an O, and this O stands for opposite, meaning the opposite sign. And so here is a minus. The original problem had a plus. Here is the opposite sign from the original equation, which is a minus. And this last one, AP, stands for always positive. And so this last term is always positive. The same acronym works for differences of perfect squares. So again, notice it has the S, which stands for same. The O stands for opposite. And the AP stands for always positive. Again, if you look here in this equation, the original problem has a minus, and so this also has a minus. It stays the same. Plus now is the opposite of the minus that was in our original equation. And then this plus, again, it's always positive at the end. We're going to talk about each of the perfect cubes right now, and we're just going to list these out because it'll be helpful as you're doing these problems today. And so 1 cubed is 1. 1 times 1 times 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. And 8 cubed is 512. And so we'll be referencing this as we are factoring. And so make sure you have those written down. All right, this first example, the first thing we need to do is make sure everything is a cube. And so if you go back and look at the perfect cube chart, okay, 8 can be written as 2 cubed. And then x is already as a cube. We'll just rewrite that as x cubed. And 125 is 5 cubed. The next thing I'm going to do is kind of write it the same as we had up here, where your first term, we're just going to put everything from the first term together in a parenthesis. And so in this case, we would write this as 2x cubed. And then we have plus, and we have our 5 cubed. If there are multiple terms at the end, I would put all of those together in a parenthesis and cube it. And so all I'm doing is just this whole factor right here is cubed. Okay, and this whole factor here is cubed. If you were to multiply this out, you would get back to that original problem. And same thing here. You multiplied this part out, you get back to your original problem. Your first parenthesis now is just whatever was here, except you don't have the cubes. And so we would write this now as 2x plus 5. So your first parenthesis is everything that you have written here except for the cubes. Your second parenthesis now, what we're going to do is we're going to write these out. So 2x cubed, we are going to write as 2x times 2x times 2x. 5 cubed, we're going to put times 5 times 5 times 5. You should always have 6 things written here. And then you're going to go through and you're going to group each of them in 2s. So what I mean by that is I have, those are my first 2 terms, my second 2 terms, and the last 2 terms. These 3 numbers, these 3 sets, are the 3 terms that go in the second parenthesis. And so we are going to go ahead and multiply these together. So 2x times 2x makes 4x squared. 2x times 5 is 10x. And 5 times 5 is 25. And that is my second parenthesis. The only thing now that we're missing is our signs, and so we're going to use our acronym of SOAP. The first parenthesis is the same. So our first thing here is the same, which we have here from our original problem. This next one is also the opposite. Opposite of plus is minus, and this last one is always positive. So we're just going to highlight these here for just a minute. Same from our original problem, opposite from our original problem, and always positive. Now, if you wanted to, we could go back and distribute and multiply this whole thing out, okay? Or you could use your area model, and when you do, you will end up back at that original problem. Now, for time's sake, right now, we're not going to do it, but if you wanted to, you could. Okay, so we're going to do some more practicing. So next one, we're going to factor 1,000. That is not on my chart, but 1,000 is 10 to the 3rd power minus w to the 3rd power, y to the 3rd power. Same as before, we want to put each of the terms kind of together in parentheses. And so we have 10 to the 3rd power minus, and then this will be wy to the 3rd power. Our first parenthesis is always the same as our original problem, except we take off the cubes. So the first parenthesis is 10 minus wy. In order to get the second parenthesis, we write out each of these cubes. So we have 10 times 10 times 10 times wy times wy times wy. And we group them in 2s. And then we multiply them together. 10 squared, or 10 times 10, is 100. 10 times wy is 10 wy. And then wy times wy will make w squared y squared. And then we put in our signs here, and so we already have our minus here. And remember that one is always the same. Our next sign is always the opposite. So opposite of minus is a plus, and the last term is always positive. Okay. So we're going to go ahead and do another one now. 216 n to the 4th plus n. So I'm looking at this right now and I'm like, well, that's not cubes. This is to the 4th power. And so we would want to check if there's a GCF, and hopefully you notice that there is a GCF, and that GCF is n. So we're going to go ahead and factor out the GCF of n. And when I do that, I'm left with 216 n to the 3rd plus, and then n divided by n makes 1. So now looking at this, hopefully you will notice that 216 is on our chart, and we can see that 6 cubed is actually 216. And so we have 6 cubed, n cubed plus, and then 1 cubed is the same as 1. Next, we'll go ahead and write these in our parentheses. So we will have 6n to the 3rd power plus 1 to the 3rd power. And we're going to write our first parenthesis, and I'm also going to bring down my GCF, which is n, And my first parenthesis is everything that's written there except for the cubes. So we have 6n plus 1. For my second parenthesis, in order to get those values, we write out each of these cubes. So we have 6n times 6n times 6n, and then the 1 3 times, 1 times 1 times 1. We group them in pairs, and that gives us each of these terms. So 6n times 6n is 36n squared. 6n times 1 is 6n, and then 1 times 1 is 1. Next, we put in our signs. The first sign is always the same as our original. The next sign is always the opposite sign, which is minus, and the last one is always positive. That's my factored answer. Okay, moving on here. Again, this doesn't look like cubes to me right now, so I'd start by checking if there's a GCF. And I know for sure, because these are both even numbers, that it's divisible by 2. So I'm going to go ahead and factor out a 2, and when I do that, I get 512 minus 27m to the 6th power. Now, when I look up here at my chart now, I can see that 512 is 8 cubed and 27 is 3 cubed. So I'm going to see if I can write this out here. So 512 is 8 cubed minus 27 is 3 cubed. And I want to write n to the 6 as a cube, okay, because I want it to be to the 3rd power. So what number, because we know powers to powers multiply, so what number would need to go here in order to multiply to make a 6? Hopefully you said 2, because 2 times 3 does make 6. And so all of these now are cubes. So we're going to go ahead and rewrite it with our parentheses. And so I have 8 to the 3rd power. And then for this term, we would write that as 3m squared to the 3rd power. All right, and so my first parenthesis now will be everything except for those cubes, and we have 8 minus 3m squared. And then also don't forget that we had the GCF of 2 that we bring down. Next, we're going to go ahead and write this out. So we're going to write out our cube, our 8 cubes, and we have 8 times 8 times 8. And then for our 3m squared, we're going to write that out 3 times. 3m squared times 3m squared times 3m squared. Next, we group them in pairs. And we multiply them out. 8 times 8 is 64. 8 times 3m squared is 24m squared. And 3m squared times 3m squared makes 9m to the 4th. Putting in our signs, we know this one is the same as our original problem. This one will be opposite, which makes it a plus. And this last one is always positive, which makes it a plus. And this is the factored form of my answer. Okay, we're going to go ahead and move on now to the next page. Okay, and so for each of these functions, write it in factored form and then determine the real and imaginary zeros. So once it's been in factored form, we're going to set each of our factors equal to 0, and some of the zeros will equal real numbers and some of them will end up being imaginary numbers. Okay, so starting here with this first one, again, it's not cubes yet, and so we would want to take out our GCF, and in this case, we can take out an x, and we're left with x cubed plus 343. Next, we want to write this as a cube, and so 343 can be written as 7 cubed. And I'm going to go ahead and just put parentheses around these two right now since they don't have multiple terms. And so we still have our GCF, which is in front, which is our x. And then my first parenthesis is going to be this problem here without the cubes, which happens to be x plus 7. My second parenthesis we get those terms by multiplying each of these out. So we have x times x times x times 7 times 7 times 7, and we group them in our pairs. And so when we do that, x times x is x squared, x times 7 is 7x, and 7 times 7 is 49. And then we'll put in our signs using SOAP. First one is the same. Next one is always the opposite, which will make this one a minus. And the last one is always positive. This is my factored form. We cannot factor any further. And so we're going to write this out as x plus 7, and x squared minus 7x plus 49. Next, now that it's in factored form, and because this was f of x equals, we can set these equal to 0. So we go ahead and mark these down, and so here we have x equals 0. Here we have x plus 7 equals 0. And then here we have x squared minus 7x plus 49 equals 0, and we're going to solve each of them. This one equals 0, already done. This one we would subtract 7 to both sides, and we get x equals negative 7. And on this one, if we tried to factor it, we would multiply over, and my multiplication number is 49, and my adding number is negative 7. The only numbers that multiply to be 49 are 1 and 49, and 7 and 7. And none of those can add or subtract in order to equal a 7. And so you're going to have to use the quadratic formula. For all of these problems, this part of the function or equation, once it's been factored, always will use the quadratic formula. In case you've forgotten, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So on this one, a is 1, b is negative 7, and c is 49. So when we plug that information into our equation for the quadratic formula, we get negative b, which would be the opposite of b, so in this case 7, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a is 1, times c is 49, all over 2 times a, which is 1. Negative 7 squared is 49. And then when you multiply negative 4 times 1 times 49, that equals negative 196. 49 minus 196 is negative 147. So this ends up, and then 2 times 1 is 2. So we get 7 plus or minus the square root of negative 147 all over 2. Remember that anytime we have a negative under our root, we take that out and it becomes an I. And so for my imaginary zeros, it is 7 plus or minus I root 147 all over 2. For my real zeros, we have 0 and negative 7. 0, negative 7. Also remember that these are points that are actually on the graph, and any imaginary numbers are not on the graph. Okay, so let's go ahead and do another one here. So 64, if we're writing that in factored form or in cubed form, it would be 4 cubed minus x cubed. We can go ahead and put our parentheses around that. And so my first parenthesis here would be 4 minus x. In order to get the second parenthesis, we will write out the cubes. 4 times 4 times 4 times x times x times x. Group them in twos. 4 times 4 is 16. 4 times x is 4x, and x times x is x squared. Using SOAP, same sign. Next one is opposite sign, which will make it a plus, and the last one is always positive. Okay, and so we set these all equal to 0. My factored form we can write right here is 4 minus x times 16 plus 4x plus x squared. We set that one equal to 0. And so we have 4 minus x equals 0. You're just trying to get x by itself. You could do this multiple ways. The easiest way, though, is just to go ahead and add x to both sides instead of subtracting 4. So when I do that, I end up getting 4 equals x, which is the same thing as x equals 4. Over here, this is not written in descending order, and so we are going to rewrite this as x squared plus 4x plus 16, and so that it's in the correct order in terms of a, b, and c, because we know that a is always with the x squared term, and so in this case, a is 1. B always comes with the plain x term, which is 4, and c is always the number without a letter, which is 16. So make sure you don't mess up there and put it in the correct order. So now I'm going to go ahead and use the quadratic formula, and so we get negative b, which would be negative 4, plus or minus the square root of b squared, which is 4 squared, minus 4 times a is 1 times c is 16, all divided by 2 times 1. Next, we simplify. 4 squared is 16, and here we have 4 times 1 times 16, which ends up making negative 64, and 16 minus 64 is negative 48. So, and then 2 times 1 is 2. So we have negative 4 plus or minus the square root of negative 48 all over 2. We know anytime there's a negative underneath, we bring that out and it becomes an I. So I have negative 4 plus or minus I root 48 all over 2. 48 though can reduce, and so 48 breaks down to 6 times 8. We know that 6 is 3 times 2, and we know that 8 is really 2 times 2 times 2. So I have a pair of 2's, another pair of 2's, and a 3 left over. So when I write this out now, I have negative 4 plus or minus, and I have 2 sets of 2's, which when they come out, they multiply together, and that makes a 4i root 3 all over 2. And then we remember that if each of these numbers can reduce, we can reduce them, and so all of them can reduce by 2. And so we divide by 2, and that becomes a negative 2. We divide by 2 here, and you still have your 2i, and we divide by 2 here, and that becomes a 1. And so when we write our imaginary zeros, it's negative 2 plus or minus 2i root 3. The real zeros, there was only one of them, and that was 4. All right, last problem. Again, this is set equal to 0. I don't always like the equal 0 on this side. You could always rewrite it and put the equal 0 on the other side if you want to, like this, and it's kind of whatever makes the most sense to you. I also notice these are not cubes, and so we are going to have to reduce and take out some values. And so what value do you think they all have in common? And hopefully you notice they each have a 5 in common. So we're going to factor out a 5, and we're also going to factor out an x. They each have an x in common. When we divide this by 5x, we end up with 8x cubed plus, and when we divide 135 by 5, if you're not sure, and you can always just do a little long division if you don't have a calculator handy, and 5 goes into 13 2 times, that's 10, subtract 3 left over, bring down the 5, and 5 goes into 35 7 times, so plus 27 equals 0. Next, we're going to set up our cubes. So here we have 2 cubed, x cubed plus 3 cubed. We're going to rewrite those with our parentheses. So I have 2x cubed plus 3 cubed. And when I start factoring now, I end up with my 5x still in front. My first parenthesis is everything without the cubes, and so that is 2x plus 3. In order to get the next parenthesis, we write out our cubes, and so that's 2x times 2x times 2x times 3 times 3 times 3, and then you pair them. We multiply those out. 2x times 2x is 4x squared. 2x times 3 is 6x, and 3 times 3 is 9. Using SOAP, same, opposite, always positive. Set the factors equal to 0. If you have 5x equals 0, we divide by 5 to both sides, we just get x equals 0. So that is a real 0. 2x plus 3 equals 0. I subtract 3 to both sides. We have 2x equals negative 3, divide by 2, and then we have negative 3 over 2. And then the last one, we have to use our quadratic formula. It's written in the correct descending order. And so A is 4, B is negative 6, and C is 9. So when we do this, we get negative B, which is 6, plus or minus the square root of B squared, which is negative 6 squared, minus 4 times A is 4, times C is 9, all divided by 2A, which is 2 times 4. So as we go through this, negative 6 squared is 36. When we multiply, negative 4 times 4 is 16, and then we need to multiply 16 times 9, which is 144. And so we're going to subtract 144, and 36 and negative 144 we subtract, and we end up getting 108, or actually negative 108. So 6 plus or minus the square root of negative 108, all divided by 2 times 4 is 8. Anytime we have a negative under a root, we take it out. So that is 6 plus or minus I root 108 all over 8. Now 108. If you're not sure, let's break it down by 2's. Okay, we did some mental math on 108 the other day, or a similar problem, but if we're breaking down 108 here, we know it factors down to be 2, and then half of 100 is 50, half of 8 is 4, so that makes 54. We can break 54 down, and that's 2, and half of 50 is 25, half of 4 is 2, so that makes a 27. 27 we know is 9 and 3, and then 9 is 3 and 3, so we have a pair of 3's, a pair of 2's, and a 3 left over. So when we write that out, that is 6 plus or minus 6I root 3 all over 8. All of those are divisible by 2, and so you get 3 and a 3I and a 4. So the imaginary zeros are 3 plus or minus 3I root 3 all over 4. And that's it.